Okay, we are going to start topical past paper questions of topic forces. Starting with the first question, we have a statement of the question that a skydiver is falling at terminal velocity. He has not yet opened his parachute. He opens his parachute. What is the direction of both velocity of the skydiver and his acceleration? Okay, so it's a free fall motion, and a skydiver is falling from some height and you have to comment about its velocity and acceleration. So as even after opening the parachute, still it will move downwards, so its velocity direction will be same. Okay, and acceleration is basically it's a rate of change of velocity. So when velocity is decreasing because it opens the parachute, so velocity will decrease. So decreasing velocity is called deceleration, so its acceleration will be opposite to the direction of motion, so acceleration direction will be opposite. Okay, so its acceleration is upward and velocity is downward. It's option C. In the second question, a bus drives along a flat road and its engine produces a force of driving that is 7,000 Newton, that is a driving force, and drag force also act on the bus. The bus has an acceleration is given and its mass is also given. You have to find the driving force. Okay, so first of all we can use Newton's second law. From Newton second law we have resultant force that is equals to F is equals to ma. That is Newton's second law. Okay, so F m is given, m is 2500 and a is 1.2. Multiplying both of them you get 3000 Newton. This is a resultant force. Okay, so now we have to make the equation. So basically there are two forces acting on the object. This is, let's suppose, F1, and the F2 is basically this driving force. Okay, and the resultant force is also in the forward direction. So why it is in the forward direction? Because the bus is accelerating. So what we can do, resultant force is the difference of two forces. Okay, resultant force, this F is equals to F1 minus D. So we have to find this D, so we have to take this on the left hand side and this F will come on the right hand side. So when we shift this D on the left hand side, there is a negative sign on the right side. When it shifts on the left side it will be positive, and this F, when it shifts toward the right side, it will be negative. F1 minus F. F1 was 7000, that is given here, and F we have found, that is 3000. That will give you 4000 Newton. That is option D. In the third question, the diagram shows four objects, each with different mass. Each object is acted on by the forces shown. Which object will experience the largest acceleration? Okay, so for the acceleration, we also use Newton's second law. F is equals to ma. So A is equals to F divided by m. So this F is the resultant force and m is the mass. Mass is given for all the objects on the diagram. The first is mass 10, this is 2, this is 5, this is 7.5. So first of all we have to find the resultant forces. So let's start from the option A. The 20 plus 20, this is a 40 Newton force toward the left side and 20 Newton force toward the right side. So it will be 40 minus 20, that will give you 20. So 20 Newton force is acting toward the left side. This is the resultant force. So for finding acceleration, A is equals to F by m. F is 20, m is 10, that will give you 2. So A is 2 for first option. Okay, 2 meter per second square, that is acceleration. Let's check the second one. Second is 10 plus 35, that will give you 45 force, and on the right side there is also 45. So 45 give you 0 resultant force. So when the force is 0, acceleration will also be 0. For the C part, there is a 20 Newton force toward the left side and mass is 5. So 20 divided by 5, that will give you 4 meter per second square. And for the option D, this is 90 and this is 35 plus 60, it will give you 65. So resultant force will be 90 minus 65, that will give you 25. So this is the force, and acceleration is, we know from the relation, A is equals to F divided by M. F is 25, M is 7.5. When you divide both of them, dividing 25 divided by 7.3, it will give you 3.3. So looking at the answers, first one was 2, second was 0, third was 4, and the last D was 3.3. So the right option we have is option C. Okay. In the fourth question, the diagram below shows the journey of the truck along a straight flat road, during which part of the journey is the resultant force on the truck equals to 0. Okay, so resultant force is 0. Resultant force is equals to 0 mean acceleration should also equals to 0. Why? Because from the Newton's second law. Newton's second law states that resultant force is directly proportional to acceleration. So acceleration is 0 when speed is constant. So we have to look for the constant speed. So if you see the graph, this portion is a constant speed. So it's option C. At option C, speed is constant, acceleration is 0, and resultant force is also 0. Question 5. A car is driving on a motorway at constant speed of 70 miles per hour. Okay, and a driver noticed a queue at traffic up ahead and began to slow down. Which diagram best describes the resultant force acting on the car that is slowing down? So you have to comment on resultant force and the car is slowing down. Okay, resultant force is basically when you have to slow a car, you have to apply a brakes. So when you apply a brake, the resultant force will be acting opposite to the direction. So if you notice from the diagram of the car, this is the front side of the car, this side is the front side of the car. Okay, so for this is accelerating case because the resultant force is forward. This is also accelerating case because still the resultant force is in the rightward direction. This is C is 0 acceleration case, it's mean constant velocity case. Okay, so this is also not the option. This one is the object front side is at this point, this is the front side of the car, and the resultant force is backwards, so it will slow down. So it's option D.